So, hello guys, welcome back to my channel. So, let me ask you a question. How many of you know about the stereoselective enolization? If you see our previous video, that is about the stereoselective enolization. So, we have discussed this question where these two substrates are treated at the similar condition and what will be the product. So, in that question, what will happen if we treat this substrate with LDA, that is lithium diisopropylamine, which is a strong base, so it will abstract one alpha hydrogen. So if you see that in this substrate, that as the base is bulkier, so preferentially this cis enolate will be formed. It is because at the trans enolate there will be a steric interaction between the tertiary group and the methyl group. So this is generally kinetic, this is the kinetic control reaction. But if the temperature is high, then the outcome may be different. So from that, it was a product. And in the similar way, if you see the video, then you will get the details about that. So now today we will discuss another question, which is, let me start that whiteboard. So this is the another question. So this question came in GATE 2005 also. That is similar type of question that we discussed in previous video. So this was the substrate which is treated with LDA 1.05 equivalent in solvent THF and temperature minus 78 degrees centigrade along with one haloalkane. So what will be the product P? So this is again the question of stereoselective enolization. So if you see that LDA lithium diisopropylamine, which can abstract, there is a probability of both the hydrogen, this alpha hydrogen and this alpha hydrogen, both the alpha hydrogen can be abstracted, and as a result the following the two enolate will be formed, either A or B. So A is kinetic enolate and B is thermodynamic enolate. Why? It is because if the temperature is lower, that is at minus 78 degrees centigrade, the reaction will be kinetically controlled. That is, it will be rate control. That is, it will be this hydrogen will be abstracted much easier because this hydrogen is sterically hindered by this methyl group. So this hydrogen is more accessible. So this is rate control reaction. So that's why if this hydrogen is abstracted by LDA, so this A enolate will be formed and it will be a kinetic enolate. On the other hand, if the temperature is high, then it will be the stability controlled. That means that will be thermodynamic. Thermodynamic enolate will be formed. This is the more substituted enolate, so this is more stable. So at the higher temperature, this thermodynamic enolate will be formed. So we had described this. At low temperature, this is the measure. At high temperature, this is the measure. Now, if it is alkylated, then which halide will be replaced? This is the question. So in our substitution reaction, if you visit that video, then you will get answer easily. And in this video also, I am going to give you the answer. Here, what will happen? This enolate will attack at this carbon, and this Br will be the leaving group. So this will be the product. So why this Br will leave instead of this Br? The reason is following three reasons. There is one is that this carbon is sp3 carbon. This is sp3 and this is sp2. Now if you see that if the nucleophile has to attack here, then there will be a repulsion between this pi electron cloud and the negative charge of this nucleophile. So obviously it will be quite difficult to attack at this carbon. So that is the one region, the electron cloud of the pi electron will repel the nucleophile in the negative electron cloud. Now the second one is, that is this bond is sp3 and S bond, while this bond is sp2s bond. So sp2s bond is quite smaller and stronger than sp3s bond. So this breaking of this bond is quite easier. This is the another region. And the third region is the emerging transition state, which will be stabilized when the carbon is sp3, because sp2 carbon is more electronegative than sp3 carbon. So if this Br left, then the positive charge will come in this carbon, and as this carbon is sp2 hybridized carbon, so there that will be the unstable one. Whereas in this when this carbocation will be formed, it will be quite stable because it is sp3 carbon, and also this electron cloud will stabilize this carbocation. So that's why the SN2 reaction will happen in this carbon. So this will be the product. So here we clear the following concept, why substitution reaction happen in this carbon, and we discussed about the stereoselective enolization. So guys, if you like this video, if you think that it is usable, then share with your friends, and also subscribe my channel to support me. Thank you. Have a good day.